Okay, my name's Jacques Carolan from the University of Bristol at the Centre for Quantum Photonics.
Okay, so your project?
Okay, I work on something called quantum computing. And what we're trying to do is build a computer using photons where the fundamental information carrier is a single particle of light. And the idea, you can think about this if you think about a classical computer, a normal computer, okay? So a normal computer might use a capacitor to store information, right? You've got a swimming pool full of electrons and all jiggling about, and you're going to call that a 0. And when you discharge it, you can call that a 1. Okay? In quantum computing, we ask what happens when you have just a single particle. Now, the rules that govern single particles are very different from that of classical physics. In particular, single particles can exist in two locations at the same time of superposition. So if over here is a 0 and over here is a 1, a quantum bit can be both a 0 and a 1 simultaneously. So what this means is you can store exponentially more information on quantum particles than you can classical particles. And we're trying to harness that to build a computer which can work things out much quicker than you can classically. So in Bristol we use photons. We use single particles light as information carrier. Now experiments used to look like this. Okay, the experiments used to be big and bulky and take up meters in space. This is basically what you need to manipulate a single qubit. Now the problem is it's bulky, it's not very stable, things wiggle about a lot. So what we've been doing in Bristol is miniaturizing these by designing and fabricating silicon waveguide circuits that take up millimeters in length. Okay, so now we have things like this. Okay, so it's a silicon waveguide circuit. The light travels down the pieces of glass, so it's completely stable. It's very small. To give you an idea, there are about 40 of those on here. So you can see it's really compact, and this is looking like something which you might be able to build a quantum computer with, and that's what we're trying to do.